Welcome to Sleep Documentary. Tonight, you're about to hatch as a baby Spinosaurus in one of the most dangerous worlds Earth has ever seen. A land filled with giant crocodiles, starving predators, violent rivers, and heat that never truly fades. And the terrifying part is, most baby Spinosaurus probably never survived their first week alive. So dim the lights, relax, and let's travel back 95 million years to prehistoric North Africa. Before we begin, I'd really appreciate it if you subscribe to the channel. It genuinely helps more than you know. And one more thing, when you were a kid, what was your favorite dinosaur? Also, where are you watching from tonight? And what time is it there right now? Let me know in the comments. And now, let's begin. 95 million years ago, long before human beings imagined deserts, oceans, or even history itself, Northern Africa was one of the most dangerous places on Earth. Not because it was empty, because it was too alive. The rivers were swollen with creatures large enough to swallow modern predators whole. Fish longer than cars drifted beneath dark water stained brown with sediment. Crocodile relatives waited motionless near muddy banks. Massive carnivorous dinosaurs crossed flooded plains searching for weakness, injury, or anything small enough to disappear between their teeth without a fight. And tonight, you are born into that world. Not as a hunter, not yet. At first, you are only a trembling animal no larger than a modern house cat, trapped inside a soft shell buried beneath damp earth near the edge of an ancient river system scientists now call the Kem beds, a region stretching across what is today Morocco and parts of North Africa. The place has become famous among paleontologists partly because almost every large predator imaginable seemed to live there at the same time. Even now, some researchers still debate how so many giant carnivores could possibly share the same ecosystem without wiping each other out. But ecosystems do not operate according to comfort. They operate according to pressure, and pressure creates specialists. Your species may eventually become one of the strangest predatory dinosaurs ever discovered. A long-snouted animal with dense bones, towering sail-like spines, and features that still divide scientists even after decades of study. But none of those evolutionary advantages matter inside an egg, because eggs are fragile. The first thing you experience is heat, not gentle warmth, crushing heat, wet heat, the kind that never fully leaves the air. The world outside your shell is humid, thick, and buzzing with insects near waterways that rise and shrink with seasonal flooding. Temperatures across the region were likely far warmer than most modern humans could comfortably tolerate for long. Dense vegetation crowded riverbanks, while vast, muddy channels twisted across enormous floodplains. And somewhere nearby, something is already searching for your nest. That may sound dramatic, but from an evolutionary perspective, nests are simply concentrated food sources. Eggs contain protein, moisture, nutrients, and almost no defense. In modern ecosystems, everything from lizards to birds to mammals raids nests whenever possible. There is little reason to think the Cretaceous behaved differently. In fact, it may have been worse. Many prehistoric predators probably relied heavily on vulnerable hatchlings because fully grown dinosaurs were so dangerous to attack directly. A newly born Spinosaurus would have represented a rare opportunity. Soft-bodied, slow, inexperienced, and exposed. You begin clawing upward through damp sediment. The shell cracks. Light enters. And immediately, the world becomes enormous. The river smells of mud, rotting vegetation, and stagnant water baking beneath the sun. Giant insects skim across shallow pools. Somewhere in the distance, another animal bellows low enough to vibrate through the ground itself. You do not understand fear yet, but your body already does. Instinct pushes you toward cover before thought can exist. That instinct may have been the only reason your species survived at all. One of the strangest things about Spinosaurus is how little scientists know about its early life stages. Adult fossils are rare enough already, but juveniles are even more mysterious. Some paleontologists suspect young Spinosaurus may have occupied different ecological roles from adults, perhaps hiding in shallower waterways or feeding on much smaller prey while avoiding direct competition with larger predators. If true, that would mean your childhood is not merely dangerous, it is isolated. Because the larger you become, the more visible you become. The problem is that visibility in this ecosystem is almost a death sentence. You move awkwardly through reeds taller than your body. Every sound matters. Tiny vibrations across mud, ripples touching shorelines, sudden silences among insects. Modern prey animals constantly interpret environmental signals to avoid predators, and ancient ecosystems were likely no different. Survival belonged not to the strongest creatures, but often to the most cautious ones, especially near water. The river beside you is not peaceful. From a distance, it almost appears calm, but calm water can hide extraordinary violence. Beneath the surface swim enormous sawfish relatives called onchopristis, their blade-like snouts lined with teeth capable of shredding flesh during rapid strikes. Lungfish drift through murky channels. Massive coelacanths move like shadows below suspended sediment. And somewhere farther downstream may lurk crocodilian relatives so large that modern Nile crocodiles would look almost modest beside them. This is important because your species seems increasingly adapted for life around water. Over the last decade, studies of Spinosaurus bones, tail structure, and body proportions have led many scientists toward the idea that it spent substantial time in aquatic environments. Dense bones may have helped control buoyancy. The long snout resembles modern fish-eating predators. Its tail may even have functioned as a powerful swimming structure. But adaptation does not guarantee safety. Young animals rarely possess the full advantages of adulthood. A hatchling heron is not a master hunter. A lion cub is not yet a lion. And you are still small enough to disappear inside another predator's throat almost instantly. The shoreline shifts beneath your feet as mud collapses near the water's edge. Something moved there. you freeze. For several seconds, nothing happens. Then, the surface breaks. Not explosively, quietly. A narrow reptilian head rises just above the river. Eyes first, then nostrils, watching. Ancient crocodilian relatives often relied on patience more than speed, and patience becomes terrifying in ecosystems where almost every creature understands ambush. You back away slowly. The animal does not pursue. Not because you are safe, because predators conserve energy whenever possible. That detail matters more than people sometimes realize. Prehistoric ecosystems were not endless action scenes filled with constant combat. Injuries could become fatal very quickly. A broken limb, infected wound, or damaged jaw might mean starvation. Most predators likely avoided unnecessary risks whenever they could, which means weakness attracted danger more than aggression did. And weakness surrounds you constantly. The Kemkem ecosystem has sometimes been described by paleontologists as one of the most predator-heavy dinosaur faunas ever discovered. Large carnivores appear unusually abundant in the fossil record there, though interpretations vary and fossil preservation biases complicate the picture. Still, even conservative reconstructions suggest this was a brutal environment where competition shaped nearly everything, including your species. Your body already carries hints of what it will someday become. The snout is slightly elongated, the forelimbs unusually strong. Tiny sensory adaptations may already help detect movement through water. But evolution builds creatures for reproduction, not comfort. There is a difference. A species can survive millions of years, while individual lives remain short, violent, and full of failure. That reality becomes clearer as night approaches. Darkness during the Cretaceous was not empty. It was loud. Insects scream from wet vegetation. Amphibians croak from hidden pools. Distant predators communicate across floodplains through deep, resonant calls that travel farther in humid air. The stars above northern Africa shine through haze and drifting moisture, while heat still radiates from mud long after sunset. You remain hidden beneath tangled roots, possibly alone. Whether Spinosaurus parents guarded nests after hatching remains unknown. Some dinosaurs likely demonstrated forms of parental care, while others may have abandoned nests entirely. Evidence across dinosaur species varies enormously. It is tempting to imagine protective parents defending hatchlings beside moonlit rivers, but nature often operates with less sentimentality than human storytelling prefers. 100 hatchlings may be born so that 2 survive, maybe 1. And survival itself can reshape behavior into something that feels almost cruel from a human perspective. Hunger arrives before sunrise. Your metabolism demands constant energy for growth. Rapid growth was one of the defining features of many dinosaur species, especially large theropods. To eventually reach enormous adult size, your body must consume extraordinary amounts of protein over time. But hunting is difficult when almost everything around you is larger. So you search the shoreline for stranded fish, insects, carrion, anything edible. The smell of decay drifts from nearby mudflats, where shrinking water trapped smaller aquatic animals during the dry season. Modern African floodplains still create temporary ecological explosions whenever water levels change, concentrating predators and prey into shrinking spaces. The Cretaceous version may have been even more extreme. You find a dead fish half buried in sediment. For a moment, survival feels possible. Then another shadow arrives first. A smaller theropod, fast, nervous. Its head jerks toward you with sharp, bird-like precision. Not large enough to threaten an adult Spinosaurus someday, perhaps, but more than capable of killing you now. You retreat immediately. Because this world does not reward pride, it rewards hesitation at the right moment. That may be one reason creatures like Spinosaurus became so specialized over evolutionary time. Competition in this environment was relentless. Every shoreline, every carcass, every nesting ground likely pushed species toward narrower ecological roles. Some hunted giant prey, some scavenged, some targeted fish, some dominated deeper water channels while others stayed near shore. And your species followed the rivers. Not because rivers were safe, because they were slightly less impossible than everything else. By midday, the heat becomes unbearable again. Moisture hangs thick across the floodplain, while distant storms build above the horizon. Seasonal flooding may have transformed these landscapes repeatedly, reshaping channels, drowning nests, and redistributing life across enormous distances. Entire territories could change within weeks, which means your first day alive is already becoming a test against forces much larger than predators alone. Heat, flood, disease, starvation, exposure. Ancient life was not merely dangerous because giant monsters existed. It was dangerous because the environment itself never stopped applying pressure from every direction at once. And somewhere beyond the reeds, hidden beneath millions of years of sediment still waiting to be uncovered, the fossilized remains of creatures like you may eventually confuse scientists, inspire arguments, and force people to rethink what dinosaurs were actually capable of becoming. But none of that matters yet. Right now, you are exhausted, still alive, and surrounded by a world that has given you absolutely no reason to believe you will survive another sunrise. The river becomes your world long before you understand what it truly is. At first, it only feels like relief. The air across the floodplain is unbearable by midday now. Heat rolls off dark mud in visible waves, while clouds of insects drift above stagnant pools thick with algae and decay. Even the wind feels wet. You spend more time hiding beneath tangled vegetation near the shoreline because open ground exposes you to everything. Larger predators overhead, faster scavengers below, and temperatures capable of draining energy frighteningly fast from a growing body. But near the river, the air changes. Cooler, moving, alive. And that is exactly what makes it dangerous. You approach cautiously through reeds taller than your back, placing your feet carefully into soft sediment that still holds the imprint of creatures far larger than you. Some tracks are fresh enough that water continues slowly filling them from beneath the mud. Massive, rounded impressions cross the bank toward deeper water channels. Three-toed prints from giant theropods vanish into dense vegetation upriver. Smaller claw marks overlap everything in frantic directions, as though the shoreline itself never truly belongs to anyone for long. That may have been the reality of these waterways during the late Cretaceous. Not stable territories, temporary negotiations. Modern rivers in predator-heavy ecosystems already create constant tension. Crocodiles gather where prey drinks. Birds stalk shallows beside animals that could kill them instantly. Fish feed beneath the shadows of larger fish. Every species wants access to water, yet water concentrates danger more efficiently than almost any other environment. Now imagine that system scaled into something prehistoric. The river beside you is enormous. Not a narrow jungle stream, but part of a sprawling network of channels, floodplains, and seasonal waterways stretching across ancient North Africa. During wetter periods, some areas may have resembled giant inland wetlands filled with fish populations large enough to support entire communities of massive predators. Paleontologists still debate exactly how aquatic this ecosystem truly was, but few disagree on one point. Life here revolved around water. And your species appears built for it. You lower your head toward the shoreline carefully. The surface trembles with movement beneath suspended sediment. Tiny fish dart away from your reflection. The smell rising from the water is strange, metallic, rotten, almost sweet beneath the heat. Decaying plants gather along muddy edges while insects skim across the surface in shimmering clusters. You drink quickly, then freeze. Something moved beneath your feet. Not imagination, pressure. A shift through water deep enough that instinct overrides curiosity before your mind fully understands why. You leap backward awkwardly, just as the river erupts beside the bank. A jaw snaps upward through muddy spray, long, narrow, packed with teeth. The predator misses you by less than a body length before crashing back into the shallows. Water explodes across reeds while the creature disappears almost immediately beneath the surface again, leaving only ripples spreading outward into silence. You stare at the river, and for the first time, you begin understanding what this place really is. Not a source of life, a hunting ground. The terrifying thing about aquatic predators is how little warning they often provide. On land, large animals make noise. They break branches. They shake ground. But water conceals movement. Modern crocodiles still kill prey partly because the attack arrives before the brain fully processes danger. Ancient rivers may have amplified that uncertainty even further. The creature that attacked you may have been a crocodilian relative, though not necessarily identical to modern crocodiles. Several large semi-aquatic predators inhabited these ecosystems, and many remain frustratingly incomplete in the fossil record. Some likely specialized in fish. Others may have ambushed nearly anything vulnerable enough to reach the shoreline, including young Spinosaurus. You retreat deeper into vegetation, breathing heavily. The river does not care. That becomes increasingly obvious over the following days. You return anyway, because survival forces compromise. Your growing body demands protein constantly now. Insects help. Carrion helps when you find it first. Small stranded animals occasionally provide enough energy to keep moving another day. But the river contains something the dry floodplain cannot offer consistently: fish, and your instincts already seem drawn toward them. Scientists have spent years arguing about exactly how Spinosaurus hunted. Some evidence suggests strong aquatic specialization, dense bones reducing buoyancy, elongated jaws ideal for gripping slippery prey, nostril placement potentially useful near water. A newer reconstruction of the tail even suggested efficient swimming ability, though debate continues over how powerful or agile Spinosaurus truly was in aquatic environments. That uncertainty matters because your species does not fit comfortably into older dinosaur categories anymore. For generations, people imagined large theropods mostly as land predators built around pursuit and ambush on solid ground. But Spinosaurus keeps disrupting that picture. Every major fossil discovery seems to make the animal stranger. Longer body, shorter legs, more aquatic adaptations. And perhaps that evolutionary path began here, in moments exactly like this, where rivers offered enormous opportunity but punished hesitation instantly. You wait motionless beside a shallow pool connected to the main channel. Small fish gather in warmer water, trapped between roots. You can feel movement through subtle vibrations across mud beneath your claws. Your snout lowers slowly. Closer, closer. Then strike. The movement surprises even you. Your jaws snap sideways through water, catching nothing except mud and reeds. Fish scatter instantly into murky depths, while you stumble forward awkwardly, nearly falling face first into the shallows. Failure burns energy. That matters more than embarrassment. Predators live inside strict biological economies. Every chase, every missed strike, every unnecessary movement costs calories. Young predators often starve not because prey is absent, but because efficiency takes time to learn. A modern lion cub can spend years practicing before becoming competent. A heron misses repeatedly before mastering precision. Even crocodiles refine ambush behavior through experience. And you may have less time to learn than almost any modern predator alive today, because nearly everything here grows fast. Fast rivers, fast seasons, fast death. You try again later, in deeper water. This time, you remain perfectly still, allowing smaller fish to forget your presence gradually. The muddy current brushes against your legs, while insects land briefly across your snout before lifting away again. Somewhere downstream, something massive crashes through reeds with enough force to shake birds into flight. You do not move. Then suddenly, the water shifts silver beneath the surface. Strike. Success. A fish rides violently between your jaws, small, barely enough to satisfy hunger for long, but real. Fresh blood mixes into river water, while instinct surges through your body almost electrically. For several seconds, the ancient world around you disappears beneath pure biological satisfaction. You are alive another day. And perhaps this is the beginning of what your species was becoming over millions of years. Not merely a dinosaur near water, but something increasingly shaped by it. Still, specialization creates vulnerability alongside advantage. That becomes clear during the dry season. The floodplain changes rapidly now. Water levels shrink beneath relentless heat. Smaller channels disconnect from the main river system, trapping fish in isolated pools where predators gather in dangerous numbers. The smell of death spreads across exposed mudflats. Rotting carcasses attract insects thick enough to darken portions of the shoreline. At first, concentrated prey seems beneficial. Then, the larger hunters arrive. You hear them before seeing them. Heavy movement, slow, deliberate. The reeds part farther downriver as another predator approaches the waterline. Not your species, different proportions, taller, more balanced for land. Massive jaws built less for gripping fish than tearing flesh from enormous prey. Carcharodontosaurus, or something close enough to make little difference from your perspective. Even as a juvenile, you instinctively understand the imbalance immediately. This predator dominates open ground in ways your growing body may never fully manage. Powerful hind limbs, deep skull, serrated teeth designed for slicing through muscle rather than trapping slippery aquatic prey. For a moment, the giant pauses beside the river, then lowers its head to drink. The scene feels strangely quiet despite the danger. No roaring, no dramatic confrontation. Just two predators existing within the same ecosystem, while pretending not to notice each other too directly. That may reflect reality more accurately than older depictions of dinosaurs constantly battling for dominance. Large predators often avoid unnecessary conflict because injury risks outweigh rewards. Even apex hunters operate within limits imposed by biology, but those limits become thinner during scarcity. The giant theropod suddenly jerks backward. Water erupts. A massive shape bursts upward from the shallows, jaws clamping toward the dinosaur's skull in an explosion of mud and spray. The attack misses cleanly, but barely. Both predators recoil instantly, one stumbling backward onto shore, the other vanishing beneath brown water almost as quickly as it appeared. Silence returns. Then the land predator walks away, not victorious, not defeated, just unwilling to gamble further. You remain frozen beneath reeds long after both animals disappear, and slowly, another realization settles into your mind. Even giants fear the river. That may explain why waterways became both refuge and nightmare for your species simultaneously. Large terrestrial predators dominated open land. Massive aquatic hunters controlled deeper channels. A semi-aquatic lifestyle may have allowed Spinosaurus access to ecological space other predators use less efficiently. But living between worlds creates constant exposure from both sides. Too aquatic for land dominance, too terrestrial for complete safety underwater. An evolutionary compromise balanced on mud. By nightfall, storms gather across the horizon. Lightning flickers silently through distant clouds, while warm rain begins falling across the floodplain in heavy, scattered drops. Water rises quickly around your feet as fresh runoff pours toward the river system. The shoreline starts disappearing, and suddenly you understand another danger hidden within this ecosystem. Flooding. Modern river systems can transform violently during seasonal storms, and ancient floodplains were likely no exception. Rising water may have drowned nests, displaced prey, separated juveniles, and reshaped entire hunting territories overnight. Some paleontologists even suspect periodic flooding helped preserve fossils within these sediments millions of years later. But preservation begins with catastrophe. The water climbs higher around submerged roots, while currents strengthen beside the bank. Debris drifts past, branches, dead fish, tangled vegetation. Somewhere nearby, another animal cries out briefly before the sound cuts off completely. You retreat toward higher ground, but even there, the river follows. Because rivers are never truly still. They expand, they erase, they consume. And somewhere within that endless movement, your species continued adapting toward a life more connected to water than almost any giant predatory dinosaur scientists had ever imagined before. If the river allows you to survive long enough to become one at all. For a while, you begin to believe the river belongs to you. Not completely, not safely, but enough that your fear starts changing shape. You are larger now than when you first crawled from the nest. Your snout has lengthened noticeably. Your forelimbs have become powerful enough to drag struggling prey from shallow water onto mudbanks. You can remain motionless for astonishing stretches of time, watching currents shift while fish move beneath suspended sediment like living shadows. Hunting still fails more often than it succeeds, but failure no longer feels automatic. And that is dangerous, because confidence arrives long before dominance does. The floodplain looks different during this season. Water has retreated from some channels, exposing broad stretches of cracked mud littered with dead shellfish, drifting bones, and stranded fish carcasses already buzzing beneath clouds of insects. Thick humidity hangs over everything. Even the air smells heavy. Warm vegetation, stagnant pools, decomposing flesh. Somewhere in the distance, thunder rolls beyond the horizon without rain ever arriving. Ancient North Africa may have felt less like a stable paradise and more like a world constantly balancing between abundance and collapse. When water expanded, life exploded. When it shrank, everything fought. And now, the fighting is getting closer. You notice it first through silence. The smaller scavengers vanish from the shoreline. Bird-like reptiles stop circling overhead. Even insects seem thinner near certain stretches of riverbank. Modern ecosystems still reveal predators this way. Prey animals often detect danger long before humans do, through scent, vibration, altered movement patterns. Entire landscapes subtly reorganize around the presence of something larger. Something arrives upstream. You see the footprints before the animal itself. 3 enormous clawed impressions pressed deep into wet sediment, each larger than your entire skull. The stride spacing alone tells a story of immense size. Mud still glistens inside the tracks, fresh. your body freezes automatically. Some instincts do not require thought. You follow the trail carefully through reeds bending beneath recent movement. Broken vegetation lines the riverbank ahead, while the smell of blood drifts heavily through the humid air. Not old blood, fresh. And then you see it. A massive carcass collapsed near shallow water, partially torn open across the ribs. The body may belong to a large herbivorous dinosaur dragged toward the river after death, though identifying species from fragments alone would challenge even modern paleontologists. What matters is not the victim, it is the thing feeding on it. Carcharodontosaurus. Even from a distance, the scale feels unreal. Its skull alone looks almost impossibly large, built less like the narrow, fish-gripping jaws your species carries, and more like a weapon designed to open flesh efficiently. Serrated teeth slide through muscle with brutal precision, while thick neck muscles wrench apart tissue in long, tearing motions. Every movement appears economical, calm, experienced. This is not an animal experimenting with survival. This is an animal built around certainty. For years, paleontologists have debated how these giant predators coexisted in the same ecosystem. Spinosaurus, Carcharodontosaurus, Deltadromeus, massive crocodilians. The Kim environment seems overloaded with carnivores by modern standards. Some researchers suspect the ecosystem may have been unusually rich in aquatic food sources. Others argue fossil preservation biases exaggerate predator abundance. There are still uncertainties, but standing here now, none of those scientific debates feel abstract, because you are looking at a creature fully capable of killing you, and perhaps one of the few animals in this world with no reason to fear what you may eventually become. The giant predator pauses suddenly. Its head lifts. For one terrible second, you think it has seen you. Then you realize it sensed something else. The river behind the carcass shifts. At first, the movement seems small, just ripples spreading across muddy water. But the surface continues rising unnaturally in one place, as though the river itself is breathing upward from below. The Carcharodontosaurus steps backward immediately, not panicked, careful. The distinction matters. Animals that survive long enough to reach massive size usually become experts at avoiding unnecessary risks. Even apex predators exist within limits. A broken leg can still mean starvation. Infection can still kill. No creature becomes dominant by gambling carelessly. The water explodes upward. A colossal crocodilian bursts from the shallows with enough force to shake mud from the riverbank itself. Jaws slam toward the carcass while water crashes across exposed roots and reeds. The giant theropod lunges sideways just in time, roaring low as both predators collide briefly in chaos before separating again. Then everything stops. The crocodilian remains half submerged, staring upward. The dinosaur stands motionless on shore. Neither attacks again, because both understand the cost. You remain hidden beneath vegetation, barely breathing, and slowly, another realization settles over you, like heat rising from the mud. There is no true ruler here. only survivors large enough to force temporary boundaries around themselves. That may be one reason the Chem-Chem ecosystem still fascinates scientists so deeply. Modern ecosystems usually separate massive predators into clearer niches. Lions dominate open savannas. Crocodiles dominate water edges. Sharks dominate marine systems. But here, the boundaries blur. River systems overlap with giant terrestrial hunters. Semi-aquatic predators move between worlds. Competition becomes layered instead of simple. And your species exists somewhere inside that overlap. Not fully terrestrial, not fully aquatic, not fully safe anywhere. As you retreat deeper into the reeds, the psychological shape of the world begins changing. Before, danger felt random. Floods, ambushes, hunger. Now it feels organized, structured. You are beginning to understand hierarchy, and you are nowhere near the top of it. The realization follows you constantly after that day. Every carcass becomes suspicious. Every shoreline crossing feels exposed. Even successful hunts lose their sense of confidence because success attracts attention faster than failure. Blood spreads through water. Movement draws eyes. Predators monitor one another constantly, even when direct conflict remains rare. Especially larger predators. You begin noticing how carefully even enormous animals behave near water crossings. A giant theropod pauses before entering open mudflats. Crocodilian eyes track movement silently from submerged channels. Scavengers wait at distances that suggest experience rather than fear alone. Everyone here understands something important. The moment you stop paying attention is usually the moment you disappear. One afternoon, heat drives you toward a narrow side channel separated from the main river by thick vegetation. Smaller fish gather here during dry periods, trapped in shrinking pools. The place seems quiet, safe enough. You move into the shallows slowly. The first strike succeeds immediately. A large fish thrashes between your jaws while muddy water sprays across your forelimbs. You pin the prey against submerged roots, tearing into flesh as instinct overrides caution for several precious seconds. Then another shadow enters the pool. Not from the water, from above. A smaller theropod crashes through the reeds with astonishing speed, jaws snapping toward your catch. You jerk backward instinctively while the intruder lunges again, shrieking sharply through the humid air. The animal is not larger than you. That is what makes the encounter unsettling. Because it is not trying to kill you. It is trying to test you. Modern predators often steal food through intimidation rather than combat. Younger lions harass older ones. Crocodiles steal kills opportunistically. Smaller carnivores exploit hesitation whenever possible. Predatory ecosystems are filled with theft because hunting itself is expensive and dangerous. The theropod lunges once more. This time, you strike back. Your jaws snap sideways with enough force to drive the animal backward into shallow water. It retreats immediately, splashing through reeds before disappearing into dense vegetation again. You remain frozen afterward, not triumphant, shaken, because something inside you has started changing too. Until recently, survival meant hiding. Now, survival increasingly demands confrontation, and confrontation attracts risk. That transition may have shaped much of juvenile Spinosaurus behavior if young individuals truly occupied intermediate ecological roles between vulnerable hatchlings and giant adult fish specialists. Growing predators often experience dangerous life stages where they become too large to hide effectively, but not yet large enough to dominate. Many never survive that transition. The fossil record rarely preserves failure clearly, but failure may have surrounded your species constantly. You notice scars more often now, not on yourself yet, but on other creatures. Bite marks along tails, missing digits, healed fractures. One crocodilian bears a damaged jaw twisted slightly sideways from an older injury. A giant theropod limps subtly across hardened mud near the riverbank before vanishing into heat haze. Ancient life was not clean, not cinematic in the heroic sense. Bodies wore survival visibly, and sometimes survival itself looked almost indistinguishable from slow destruction. Storm season returns weeks later. Warm winds sweep across the floodplain, carrying the smell of rain before clouds fully arrive. Lightning flickers through dense skies, while distant thunder rolls continuously across open wetlands. Water levels begin rising again, reconnecting isolated pools back into larger channels. With fresh water comes movement. Fish migrate, scavengers spread out, predators reposition. The ecosystem breathes differently. You travel farther from familiar territory now, following flooded channels into regions where vegetation thickens into tangled forests bordering deeper water systems. Strange sounds echo through the trees at night. Low, resonant calls from unseen animals, splashing movements large enough to shake entire root systems beneath the waterline. And then, one evening, you find evidence of your own species. The tracks appear near a muddy embankment exposed by receding water. Huge, long-toed, distinctive. At first you only notice size, but then something else becomes obvious: the drag marks beside them. Sweeping impressions through wet sediment, almost like giant tails or bodies shifting near shallow water. Another Spinosaurus passed through here recently, possibly an adult. You follow cautiously through dense reeds until the smell reaches you first. Fish, mud, and something heavier beneath it. Not decay, presence. The figure emerges gradually from river fog at dusk. Enormous sail rising above vegetation. Long snout angled toward dark water. Motionless, except for slow breathing. For the first time in your life, you are looking at what you may someday become. And strangely, it does not look like the ruler of this world. It looks like part of it. That distinction feels important. The adult does not patrol territory like a lion king from human imagination. It does not challenge the horizon. It waits, watches currents, conserves energy. Entire body shaped less around domination than adaptation. Perhaps that is why Spinosaurus became so unusual, not because it conquered the ecosystem completely, but because it learned how to survive an ecosystem too violent for simpler strategies. Still, even this giant remains cautious. The adult suddenly lifts its head toward distant movement upriver. Another predator call echoes faintly through humid darkness. The giant Spinosaurus steps backward into deeper water almost immediately, not fleeing, avoiding. And as storm clouds gather above ancient North Africa once again, you finally understand the truth this world has been teaching since the moment you hatched. Being enormous does not make you untouchable. It only changes what is capable of killing you. By now, the river recognizes you, not as a ruler, not even as a fully grown predator, but as something becoming increasingly difficult to classify. You are larger than most animals along the shoreline now. Smaller scavengers retreat when you approach carcasses. Fish explode from shallow pools the moment your shadow crosses the water. Even some young crocodilian predators hesitate before drifting too close. Your body carries weight differently than it once did. Heavier through the chest, stronger through the forelimbs, more stable near water than on dry ground. And yet, the strangest change is not your size. It is your shape. Because the older you become, the less you resemble the image people usually imagine when they hear the word dinosaur. The floodplain stretches endlessly beneath white heat this afternoon. Humid wind rolls across shallow channels, while dragonfly-like insects drift above mats of floating vegetation. In the distance, thunderheads gather over darker wetlands where deeper water cuts through the landscape like veins across ancient skin. You move through knee-deep shallows slowly, almost silently now. The long snout that once felt awkward has become one of your greatest advantages. Narrow, sensitive, perfect for detecting movement near the waterline. Rows of conical teeth line your jaws, not blade-like tearing weapons like those carried by Carcharodontosaurus, but smoother, stronger structures, better suited for gripping struggling prey. Fish hunter teeth. That distinction matters. Predators reveal their evolutionary history through anatomy long before behavior becomes obvious. Lions and crocodiles kill differently because their bodies solve different problems. Sharks, wolves, herons, and bears all hunt meat, yet their skeletons tell completely different stories about the environments that shaped them. Your skeleton tells a strange story, and even millions of years later, scientists are still arguing about exactly what that story means. You stop near a shallow embankment where warm water spills slowly from a flooded side channel into the main river. Fish gather here during the hottest parts of the day, drawn toward oxygen-rich currents moving through submerged roots. You remain motionless. The sail along your back rises above the waterline like a dark ridge. That sail may be the most mysterious part of you all. Even now, no one knows with complete certainty why your species evolved it. Some paleontologists suspect it helped regulate body temperature, acting as a structure rich with blood vessels capable of releasing heat into the air or absorbing warmth during cooler hours. Others think the sail may have played a role in visual communication, intimidating rivals, attracting mates, signaling identity across wetlands where visibility constantly shifts through reeds and river fog. There are even hypotheses suggesting fat storage, species recognition, or combinations of several functions at once. Nature rarely builds enormous structures without reason, but evolution also does not always produce perfect designs. Sometimes, features emerge through complicated chains of pressures, compromises, and unintended consequences. Peacocks carry impossible tails. Moose grow antlers large enough to become burdens. Some extinct animals evolved structures so bizarre that modern scientists still struggle to explain them cleanly. And you may belong in that category. A giant predator with a crocodile-like skull, dense bones, short hind limbs, enormous claws, and a towering sail rising from its spine should not exist so easily inside older dinosaur frameworks. That may be why Spinosaurus continues unsettling paleontology itself. The deeper researchers look, the stranger the animal becomes. You strike suddenly into the water. A large fish thrashes violently between your jaws, while muddy spray bursts across your sail and shoulders. The prey twists hard enough to shake your entire neck sideways, but your teeth hold firm. Not slicing, trapping. This may have been one of the key differences between your species and the giant terrestrial hunters sharing the floodplain. Carcharodontosaurus possessed blade-like teeth designed for cutting flesh from massive prey animals. Your jaws appear optimized for resisting struggling aquatic prey instead. Even your snout shape resembles modern fish-eating predators more than traditional theropod dinosaurs. But specialization creates strange trade-offs. You drag the fish toward shore awkwardly, forelimbs digging into wet sediment while your hind legs struggle briefly against deeper mud. That imbalance follows you constantly now. Your growing body feels increasingly efficient near water and increasingly uncomfortable farther from it. The change is subtle at first, then impossible to ignore. Your legs are shorter than those of many large theropods. Your center of gravity sits differently. Walking across open floodplains sometimes feels unstable, compared to moving through shallow channels where water helps support your weight. For decades, older Spinosaurus reconstructions often portrayed the animal standing tall, like a more traditional giant theropod. But newer fossil discoveries complicated that image dramatically. Some reconstructions now suggest proportions unlike almost any other large predatory dinosaur known. Lower slung, more aquatic, perhaps less adapted for sustained movement on dry land than earlier scientists imagined. Not everyone agrees fully on those interpretations, and that disagreement itself is fascinating. Because your species exists inside one of paleontology's strangest problems, every major discovery seems to rewrite the animal almost completely. At one point, Spinosaurus was imagined as a fairly standard giant predator with a sail. Then came elongated jaws. Then dense bones. Then shorter hind limbs. Then a paddle-like tail. Each new fossil added another layer of uncertainty. It is almost as though the animal refuses to stay still long enough for science to define it comfortably. The river current presses gently against your body, while distant storm clouds darken overhead. You can feel subtle vibrations through the water now, movement farther downstream. perhaps fish schools, perhaps something larger. Your senses are changing alongside your body. Modern crocodilians possess extraordinary sensitivity around their jaws, capable of detecting tiny pressure changes in water. Some researchers have wondered whether Spinosaurus may have evolved similar abilities to assist hunting in murky river systems where visibility remained poor. Evidence remains incomplete, but the possibility fits your world disturbingly well. Because sight alone is unreliable here, the river hides too much. You move deeper into the channel, carefully. Water climbs along your sides, while your sail remains exposed above the surface, like the fin of some ancient living machine. Fish scatter beneath you in silver flashes. Thick humidity presses down from above, while submerged roots slide beneath your claws. And suddenly, for a brief moment, movement feels easy. Not fast, not elegant, but natural. Perhaps this is what your species was evolving toward all along. A predator not fully bound to land anymore. That idea still sparks debate today. Some paleontologists argue Spinosaurus may have been highly aquatic, capable of pursuing prey actively through water. Others suggest a more shoreline-based lifestyle, similar to modern herons or grizzly bears, wading hunters rather than true swimmers. Part of the challenge comes from the fossil record itself. Fossils preserve fragments, not behavior. Bones reveal structure, but behavior must often be reconstructed through comparisons, biomechanics, and educated interpretation. And your anatomy refuses simple comparisons. You are built from contradictions. Powerful forelimbs, but awkward balance. Predatory size, but fish-specialized jaws. A sail too large to ignore. A body seemingly caught between ecological worlds. The deeper water cools your skin, while rain finally begins falling from distant storm bands. Large, warm drops strike the river surface in expanding circles. Thunder rolls low across the wetlands. Then, another Spinosaurus appears. The adult emerges gradually through reeds farther upstream, larger than any individual you have encountered directly before. Massive claws drag briefly through mud before disappearing beneath shallow water again. Its sail rises almost impossibly high against the darkening sky, and for the first time, you see your species clearly beside another giant predator of the same kind. The differences are unsettling. The adult moves with practiced efficiency near water, but surprising caution on land. Its posture shifts constantly depending on terrain. In deeper channels, it appears almost comfortable. On exposed mudbanks, movement becomes slower, heavier, less graceful. This may explain something important about your species. Perhaps Spinosaurus did not become strange because evolution was aiming toward perfection. Perhaps it became strange because the environment itself forced compromise. The rivers offered enormous food sources unavailable to most giant theropods. Fish populations may have supported predators too specialized for open land dominance. But adapting toward aquatic life while retaining massive body size likely created enormous structural challenges. Your species may represent evolution experimenting in real time, not a final answer, an adaptation still balancing itself. The adult lowers its snout toward the water suddenly, then strikes. A huge fish erupts from the river, thrashing violently, while the giant predator pins it against submerged roots, using both jaws and forelimbs together. Water explodes around the struggle, while rain intensifies overhead. The technique feels familiar instantly, not inherited consciously, embedded. That matters because instincts are evolutionary memory written into muscle and reaction. Millions of years of pressure shape behavior long before thought exists. Your species has been learning this river across generations, stretching farther backward than comprehension itself. And the river has been reshaping your species in return. Lightning flashes overhead. For one brief second, the adult Spinosaurus stands illuminated against storm-dark water, enormous sail rising above flooded reeds, elongated jaws dripping river water, body caught somewhere between dinosaur, crocodile, and something uniquely ancient that no modern ecosystem has truly replicated since. Then darkness returns, and another realization settles slowly into your mind. The body you are growing into is not simply unusual. It may be one of the strangest experiments evolution ever allowed to survive. The older you become, the less your life revolves around fear, and the more it revolves around hunger. At first, hunger arrived as discomfort, an ache that pushed you toward shallow pools and insect-filled shorelines, something temporary, manageable. But now, it feels heavier than that, constant, a pressure that follows you through every movement across the floodplain, like heat trapped beneath your skin. Your body is enormous compared to what it once was, and enormous bodies are expensive. The river glows dark gold beneath the late afternoon sun as you move slowly through knee-deep water. Dragonflies skim the surface. Warm wind bends tall reeds in waves, while distant thunder drifts somewhere beyond the wetlands. The air smells of algae, mud, rotting fish, and rain that still hasn't arrived. Everything here feels swollen with life, yet somehow it never feels like enough. That may have been one of the defining realities of giant predators during the late Cretaceous. Size creates power, but it also creates relentless biological demand. A growing Spinosaurus could not survive on occasional success. Your muscles, organs, immune system, and rapidly expanding skeleton all require extraordinary energy every single day. And, unlike smaller predators, you cannot disappear quietly when food becomes scarce. You need too much. The fish population has shifted again with the changing season. Some deeper channels remain active, but many smaller waterways are shrinking beneath relentless heat. Water trapped in isolated pools grows warm and cloudy. Dead fish float belly up near muddy banks, while scavengers gather in dangerous numbers around the edges. The floodplain is beginning to tighten. That happens in modern ecosystems too. During droughts, rivers become traps disguised as opportunities. Animals crowd closer together because water still exists there, but concentration increases competition just as quickly as it increases access to prey. Ancient North Africa may have amplified that effect to terrifying levels. You pause near a shallow embankment where the river narrows between exposed roots and dark sediment. Fish move beneath the surface, not enough to feed you fully, but enough to matter. Your snout lowers slowly toward the water. Stillness, patience, then strike. A large fish twists violently between your jaws while muddy water bursts upward around your chest. You pin the prey against submerged roots, claws sinking deep into soft sediment as blood spreads through the current. For several seconds, instinct drowns everything else. Then, the river changes. The fish stop moving. The current shifts direction slightly, and somewhere downstream, something larger notices the blood. You feel it before seeing it. Pressure through water. Movement. The river has taught you this language over time. Tiny vibrations now carry meaning instinctively. Feeding activity. Panic. Migration. Danger. The muddy current acts almost like a second nervous system extending beyond your body. You release the remains of the fish immediately. Too late. A massive shape glides beneath the surface toward you with frightening speed. The water bulges upward around its back before a huge crocodilian head erupts from the river beside the carcass, jaws snapping shut where your body stood moments earlier. You leap backward violently into shallower water. The predator ignores you. It wants the fish. That detail matters, because this ecosystem is not driven purely by killing. It is driven by efficiency. Modern crocodiles often steal prey rather than hunt directly when given the opportunity. Large predators conserve energy obsessively because survival depends less on dramatic victories and more on minimizing costly mistakes. Ancient ecosystems likely followed the same brutal logic. You retreat toward shore while the crocodilian tears apart what remains of your catch beneath swirling, muddy water. And once again, the same realization returns. Nothing here belongs entirely to you, not even your own food. Rain finally arrives that night. Warm sheets of water hammer the floodplain, while lightning flashes above distant wetlands in pale blue bursts. Rivers rise rapidly beneath the storm, swallowing low mudbanks and reconnecting isolated channels into larger, flowing systems again. Fish migrate with the changing currents. Smaller scavengers spread outward. Predators reposition themselves almost immediately. The ecosystem breathes through water, and hunger follows the breathing. You travel farther than usual over the next several days, following newly flooded channels deeper into unfamiliar territory. The landscape changes constantly now. Some areas become temporary lakes filled with drifting vegetation and trapped fish. Others transform into black mud plains, crawling with insects and half-submerged carcasses left behind by rising water. Death feeds life here with almost disturbing efficiency. A decaying fish attracts smaller scavengers. Those scavengers attract larger hunters. The larger hunters leave remains. Then insects, bacteria, heat, and water continue the process again. Nothing stays unused for long. That may be why giant predators could survive in such numbers across this ecosystem at all. The rivers produced staggering biological productivity compared to surrounding dry environments. Fish populations alone may have supported enormous carnivorous pressure, especially for specialized hunters like your species. But productivity is not stability. A productive ecosystem can still collapse temporarily under seasonal pressure, and when it does, hunger changes behavior. You discover that reality near sunset several days later. The smell reaches you first. Rot, heavy, sweet. A carcass lies half-submerged beside a flooded channel. Some massive aquatic animal already torn open across the abdomen. Clouds of insects drift above exposed flesh, while scavenger tracks crisscross the surrounding mud. You approach cautiously, not because you fear the carcass itself, because carcasses attract company. Modern predators frequently scavenge when opportunities appear. Even highly capable hunters rarely waste free calories. Fossil evidence suggests many large theropods likely scavenged opportunistically as well, despite older portrayals focusing only on active hunting. The distinction between hunter and scavenger may have been far blurrier than people prefer to imagine. You lower your head toward exposed flesh carefully. Fresh enough. Edible. Then movement erupts from the opposite side of the carcass. Another Spinosaurus. You freeze instantly. The other individual is smaller than the massive adults you have occasionally glimpsed through river fog, but larger than you. Scar tissue crosses part of its snout. One sail spine appears damaged near the top, bending slightly sideways against the darkening sky. It stares at you silently. No roar, no dramatic display, just calculation. That silence feels more dangerous somehow. Large predators rarely seek combat automatically because combat is expensive. A deep bite infection, damaged limb, or broken tooth can become fatal long after the actual fight ends. Even modern apex predators often resolve tension through posture, intimidation, or strategic retreat rather than direct violence. But hunger changes thresholds. The other Spinosaurus steps toward the carcass slowly. You do not move. Its claws sink deep into wet mud while river water drips from its jaws. The smell of blood thickens around both of you beneath the humid evening air. Another step. Closer. Then suddenly, it lunges sideways toward the carcass itself, tearing free a massive chunk of flesh, before backing away again immediately. A warning, not an attack. You understand. The carcass is large enough to share temporarily, but only temporarily. The two of you feed in silence, while insects swarm around exposed tissue and thunder rolls low across distant wetlands. Occasionally, the other predator lifts its head to watch the surrounding floodplain rather than you. That detail feels important, because even here, beside free food, neither of you truly relaxes. The river never allows complete safety. Something larger could still arrive. And eventually, something does. The water nearby shifts unnaturally, Both of you react instantly. Heads rise, bodies tense. The current bulges upward beside submerged roots, while smaller scavengers explode away from the shoreline in panic. Then a gigantic crocodilian shape emerges slowly from deeper water, eyes fixed directly toward the carcass. No hesitation, no fear. The other Spinosaurus backs away first. Not dramatically, practically. You follow immediately. Within seconds, the crocodilian dominates the carcass alone, while both of you retreat into reeds under gathering darkness. The message is clear. Even now, after all your growth, after surviving floods and predators and starvation and storms, there are still moments when the smartest decision is simply leaving. That truth reshapes something inside you over time. The fantasy of dominance begins fading. What replaces it is stranger, more ancient. An understanding that survival in this ecosystem is less about conquering territory and more about navigating pressure without collapsing beneath it. Every day becomes negotiation. With heat, with injury, with scarcity, with larger predators, with changing rivers, and most of all, with hunger itself. Because hunger never truly ends. The larger your body becomes, the worse it gets. You notice this during long, dry stretches especially. Fish migrate unpredictably now. Some hunting days produce almost nothing. Other days bring sudden explosions of opportunity when shrinking channels trap prey in dense concentrations. Success feels random from moment to moment, and randomness is dangerous for large predators. Modern ecosystems reveal this clearly. Big carnivores often live close to starvation despite their power. Lions fail hunts constantly. Sharks travel enormous distances searching for food. Crocodiles survive partly because their metabolisms allow long fasting periods. Giant predators exist near energetic limits far more often than humans usually imagine. Your species may have balanced on those limits constantly. The river itself seems unstable now. Water levels fluctuate harder with seasonal shifts. Mudflats widen. Fish carcasses appear more frequently along exposed shorelines. Entire sections of floodplain smell of decay beneath the crushing heat. Some paleontologists suspect ancient North Africa periodically experienced intense environmental fluctuations capable of reshaping habitats rapidly. If true, specialized predators like Spinosaurus may have lived dangerously close to ecological vulnerability despite their size. Specialization creates efficiency, but it also creates dependence. And dependence becomes terrifying when environments change. You feel that dependence one evening while standing chest deep in dark water beneath a sky stained orange by dust and distant storms. Fish activity has been poor for days. Your ribs no longer press beneath the skin the way they once did, but hunger still sharpens movement, focus, aggression. The river feels quieter tonight, wrong somehow. Then you realize why. The fish have moved deeper, and suddenly the terrifying possibility becomes impossible to ignore. What happens if the river stops feeding you at all? Lightning flickers silently beyond the horizon, while warm wind ripples across black water around your body. Somewhere far downstream, another predator calls through the darkness. Low, distant, ancient. You remain motionless in the river, waiting for movement beneath the surface. Waiting for life. Because in this world, the difference between giant predator and starving animal can disappear faster than the river itself changes direction. At some point, survival stops feeling like a battle against the world around you and starts feeling like a battle against your own body. The change happens slowly enough that you barely notice it at first. You are enormous now. Not fully grown, perhaps, but large enough that smaller predators no longer test you casually near carcasses. Large enough that fish explode through the surface in panic when your shadow crosses shallow channels. Large enough that the river itself bends differently around your movement. But size carries consequences that younger animals cannot imagine, especially in a world built from mud, heat, unstable water, and constant pressure. The morning air already feels heavy long before sunrise. Thick humidity drifts across the floodplain while dark clouds gather low above distant wetlands. Somewhere beyond the reeds, insects scream in endless waves loud enough to blur into the sound of the river itself. You move slowly through soft shoreline sediment. Too slowly. Your body sinks deeper into the mud now than it once did. Every step leaves massive impressions filled instantly with brown water. Muscles across your hips strain harder, pulling free from unstable ground, while your heavy forelimbs compensate automatically for balance. That balance has become increasingly strange over time. Even you can feel it. Your center of gravity sits farther forward than most giant predators sharing this ecosystem. The long torso, dense bones, enlarged forelimbs, reduced hind limbs. All of it changes the way movement feels across dry terrain. And the larger you become, the more noticeable the problem gets. For decades, scientists struggled to understand exactly how Spinosaurus moved. Older reconstructions often showed the animal standing upright like a more traditional theropod predator, balanced efficiently over powerful hind legs. But newer fossil discoveries complicated that picture dramatically. Shorter hind limbs, heavier body proportions, dense skeletal structure. Some researchers even proposed that Spinosaurus may have spent substantial time moving on all fours while navigating certain terrain, though interpretations remain debated. Others argue the animal still retained primarily bipedal movement, despite its unusual anatomy. That uncertainty matters because your body no longer behaves like the body of a simple land predator, and nature rarely forgives awkwardness. The mud beneath you suddenly shifts sideways. One rear foot sinks deep enough that panic surges through your nervous system instantly. You wrench upward violently, claws tearing through wet sediment while your massive body tilts dangerously off balance toward deeper water. For several terrifying seconds, you cannot move cleanly at all. The river presses against your side, mud grips your leg. Your own weight becomes the problem. Then, finally, the trapped foot tears free with a violent sucking sound that sprays black sediment across your belly and forelimbs. You stumble forward heavily into shallower water, breathing hard. Nothing attacked you. Nothing chased you. And yet, you came frighteningly close to disaster anyway. That may have been one of the hidden dangers facing giant animals in ancient floodplain ecosystems. Modern elephants still become trapped in mud during drought conditions. Large herbivores drown in river crossings. Even crocodiles occasionally die stranded where water recedes unexpectedly. Massive bodies are powerful, but they are also difficult to rescue once something goes wrong. The riverbank ahead is lined with old bones partially exposed by erosion. Fish vertebrae, broken ribs from some larger animal, fragments scattered through dark sediment like pieces of unfinished memory. Paleontologists today often discover fossils in places exactly like this because floodplains preserve death unusually well. Water buries, mud seals. Rivers erase landscapes while secretly storing them beneath layers of sediment for millions of years. Sometimes entire lives disappear this way because of one bad step, one infection, one drought, one injury that heals incorrectly. You understand that more clearly now because your body already carries damage of its own. A deep scar cuts along your flank where another predator once caught you near a carcass during the dry season. The wound healed, but not cleanly. Thickened tissue pulls awkwardly when you move too quickly across uneven ground. One claw remains cracked near the tip after striking submerged stone during a failed hunt weeks earlier. Pain has become part of movement. Not constant, just present. Ancient life rarely stayed uninjured for long. Modern predators reveal the same truth constantly. Wild lions carry broken teeth. Crocodiles lose limbs. Wolves survive with shattered ribs and infected bite wounds. Life in predator-heavy ecosystems wears bodies down over time until survival itself begins resembling controlled collapse. And your body may have been especially vulnerable to that process because specialization creates structural stress. You lower yourself carefully into deeper water, where buoyancy eases pressure across your limbs almost immediately. The relief feels undeniable. Water supports your weight in ways dry land no longer does comfortably. Perhaps that was part of the reason your species became increasingly tied to rivers, not merely for food, for movement itself. Some researchers have suggested dense bones helped Spinosaurus remain stable underwater while hunting fish. Others believe the body became so specialized for semi-aquatic life that moving efficiently across open land may have grown increasingly difficult compared to other giant theropods. The truth remains uncertain, but sitting here now, beneath warm brown water, feeling the river carry part of your weight for you, the idea no longer feels impossible. Rain begins falling lightly across the floodplain. Tiny circles spread across the river's surface, while distant thunder rolls through humid air. Fish move below you in nervous flashes, sensing pressure changes before storms fully arrive. You prepare to strike. Then, pain explodes through your jaw, not from attack, from inside. You jerk backward violently, confused at first, before realizing one of your teeth has cracked deeper than expected while clamping on to struggling prey earlier that morning. The sensation is blinding. Modern crocodiles and predatory mammals suffer similar injuries constantly. Broken teeth expose nerves. Infections spread through damaged tissue. Eating becomes harder. Hunting becomes riskier. And, unlike humans, wild predators do not rest while recovering. They continue hunting until they fail. Or heal, if they heal. You open your jaws slowly beneath the rain while blood mixes into the river around you. This is another hidden weakness of giant predators people rarely imagine. Strength creates opportunities for injury, simply because powerful bodies generate tremendous force. A large predator striking prey, bone, stone, or another predator incorrectly can damage itself catastrophically in seconds. There are no second chances in ecosystems like this, only adaptation or decline. The storm intensifies by afternoon. Floodwaters rise rapidly through smaller channels, while warm wind bends reeds nearly flat against the shoreline. Lightning flashes overhead in pale white bursts, illuminating the floodplain in brief, violent fragments. And through one of those flashes, you see another Spinosaurus moving upriver. Old. Not ancient, perhaps, but older than most individuals you have encountered directly before. Its sail bears uneven edges scarred by age or injury. One forelimb moves stiffly through shallow water. Several teeth are visibly missing along one side of the elongated snout. Yet, it still survives. That detail feels important, because survival at large size may depend less on perfection and more on endurance. The older animal stops near a flooded embankment where fish gather beneath submerged roots. Instead of lunging aggressively into deeper water, it hunts slowly, carefully, conserving movement. Experienced predators often become economical rather than explosive with age. Modern crocodiles survive partly through patience. Older lions avoid unnecessary chases. Injury teaches efficiency because wasted energy becomes increasingly dangerous over time. You watch the older Spinosaurus feed in silence beneath the storm, and for the first time, you glimpse your future not as dominance, but maintenance. A body slowly negotiating with damage. The rain cools your sail, while muddy water swirls around submerged trees and exposed roots. Somewhere nearby, another large predator bellows through the storm-dark wetlands, but neither of you reacts dramatically. Everything here is already carrying too much weight to waste energy proving strength constantly. Night arrives under heavy cloud cover. The floodplain smells of wet vegetation and exposed mud, while insects gather thick around standing water. You move toward higher ground carefully, because flooded channels hide hazards impossible to see clearly in darkness. Then suddenly, the ground collapses beneath your weight. Not completely, just enough. A buried section of saturated mud gives way near the edge of an eroded embankment, sending one side of your body crashing downward violently. Pain tears through your shoulder, as claws scrape uselessly against collapsing sediment. For several terrifying seconds, you slide toward deeper water. Your own mass drags you downward. The river surges against your side. Mud traps your limbs. Panic arrives instantly, because instinct understands something your mind barely processes. Large animals do not escape easily once gravity begins winning. You thrash violently, driving your forelimbs deep into firmer sediment, higher along the bank. Muscles strain. Mud tears loose around your body in heavy, collapsing waves. Then, finally, you wrench yourself free, breathing hard, covered in black sediment, alive, but limping now. The shoulder hurts immediately when you place weight against it. Not broken, perhaps, but damaged enough that movement feels uneven. And suddenly, the entire world changes again, because every hunt now carries additional risk. Every river crossing becomes more dangerous. Every predator watching from deeper water sees weakness before you do. This may be one of the cruelest realities of prehistoric life. Bodies evolved for survival could also become traps under the wrong conditions. Spinosaurus may have been one of evolution's strangest predators, uniquely adapted for a world of rivers and floodplains, unlike anything alive today. But strange adaptations are often delicate balancing acts. Too much weight, too much specialization, too much dependence on unstable environments, and eventually, the body designed to help you survive begins demanding more from you than the world can easily provide. The storm passes slowly overnight. By dawn, fog drifts across flooded wetlands, while warm sunlight breaks through low clouds in scattered beans. The river glows gold again. Fish move beneath the surface. Insects return. The world continues exactly as before. But your shoulder still hurts when you move. And for the first time since hatching, you begin to understand something deeply unsettling. You are not dying because the world is weak. You are surviving because your body has not failed yet. The older you become, the lonelier the river feels. Not empty, never empty. The wetlands still pulse with movement every hour of the day. Fish churn beneath muddy channels. Crocodilian eyes drift silently above black water at dusk. Giant predators leave fresh tracks along exposed banks every morning before heat hardens the mud again. Insects still scream through the reeds after sunset, while storms gather over distant floodplains like dark mountains made from rain. Life surrounds you constantly, and yet your species rarely seems to move together. That may have been one of the strangest things about becoming an adult Spinosaurus. You grow enormous without ever truly becoming social. The river at dawn glows bronze beneath low fog drifting across the wetlands. Warm air rises from shallow water, while birds scatter from flooded trees ahead of your movement. Your injured shoulder still aches during colder mornings now, though the pain has dulled into something familiar, less an injury than a permanent negotiation between flesh and survival. You move slowly through the shallows, scanning the waterline, not for prey this time, for another presence. Something inside you has changed over recent seasons. Hunger still dominates much of your life. Survival still shapes every movement. But another instinct has begun pressing upward beneath everything else, older and deeper than fear. The need to find another of your kind. Not to hunt beside, not to live beside, just long enough to continue the species. That may sound simple from a modern human perspective, but reproduction in prehistoric ecosystems was rarely peaceful. Courtship itself could become dangerous when giant predators carried bodies built for violence. Modern crocodiles injure one another during mating disputes. Large birds perform exhausting territorial displays. Even herbivores regularly kill rivals during breeding seasons. And your species may have faced an especially difficult problem. How does an animal this large, this specialized, and this solitary even find a mate across floodplains stretching hundreds of miles? The fossil record cannot answer that directly. No one has ever found a preserved Spinosaurus mating ground or courtship display frozen perfectly in time. Paleontologists infer behavior mostly through anatomy, comparisons with living animals, and environmental logic. But behavior leaves shadows even when evidence disappears, and your body may already carry clues. The sail rising from your spine catches the morning light as you move through shallow water. Its surface flushes darker beneath increased blood flow during the heat of the day. Some scientists have wondered whether structures like this may have played visual roles during mating displays or species recognition. In dense wetlands filled with reeds, fog, and shifting waterways, a tall sail visible above vegetation could become useful long before physical contact ever occurred. Not necessarily beautiful, just noticeable. Nature often values visibility more than elegance. You stop near a flooded sandbar where massive tracks crisscross soft sediment. Most belong to other predators passing through the area over recent days, but one set feels different immediately. Spinosaurus, fresh. The impressions are enormous, deeper than your own, leading toward a side channel lined with thick vegetation and black water. Broken reeds still drift slowly across the surface where something large moved through recently. You follow carefully, not cautiously in the way you once avoided predators, carefully in another sense, because adult predators rarely meet without risk, even among the same species. The river narrows ahead into a slow-moving channel surrounded by exposed roots and low trees leaning over dark water. The smell reaches you first. Fish, wet mud, blood, and another scent beneath it that feels strangely familiar. Then you see the sail, huge, dark against morning fog. The other Spinosaurus stands half submerged near the far bank, almost motionless except for slow breathing. Water drips from elongated jaws while sunlight catches scars crossing one side of the sail in pale, uneven lines. An adult female, perhaps. Or perhaps not. Sexing dinosaurs from fossils remains extremely difficult unless direct evidence exists, and living behavior can only be reconstructed through speculation. Some paleontologists suspect larger sails may have played roles in visual signaling between sexes, but certainty remains impossible. Still, something about this encounter feels different from territorial tension. The other Spinosaurus watches you silently. No immediate aggression, no retreat, just awareness. You lower your head slightly while remaining in shallow water. The distance matters. Large predators often communicate through posture long before violence begins. Crocodilians use body position and movement patterns. Birds rely on visual displays. Mammals interpret tension through tiny behavioral shifts invisible to untrained eyes. Perhaps your species developed similar systems because direct combat carried catastrophic risks. Your bodies are too large for reckless injury now. The female moves first, not toward you, toward deeper water. She circles slowly through the channel while fish scatter beneath the surface in silver flashes. The sail along her back cuts through river fog like the fin of some ancient submerged machine. Then she stops again, waiting. It is impossible to know exactly how Spinosaurus courtship behaved, but modern semi-aquatic animals provide intriguing possibilities. Crocodilians communicate through low vibrations traveling across water. Some birds use elaborate movement displays. Even subtle body positioning can signal strength, health, or reproductive fitness. And health matters enormously in brutal ecosystems. A weak mate risks weak offspring. Injury matters. Parasites matter. Efficiency matters. The river selects constantly. You move closer through the shallows, slowly. The female does not retreat, but tension remains heavy beneath every movement. Giant predators rarely abandon caution completely, because instinct remembers how quickly interactions can become fatal. Then, another sound cuts through the wetlands. A low, resonant call somewhere beyond the trees upstream. Another Spinosaurus. The female reacts instantly. Her posture changes. The stillness disappears. Water churns around her legs while she turns sharply toward the direction of the sound. Moments later, another sail emerges beyond the reeds upriver, larger than yours, heavily scarred along one side, moving directly toward the channel. And suddenly, the atmosphere changes completely. The male enters the water without hesitation. Heavy movement sends waves across the narrow channel, while fish burst away through submerged roots. He keeps his head low, eyes fixed toward you rather than the female. No roaring, no dramatic cinematic challenge. Real predators often avoid spectacle before violence. The danger comes from certainty. You remain motionless. The larger male approaches another few steps through the shallows until the water nearly touches the base of his sail. Scar tissue crosses his jaws. One forelimb appears thicker than the other from old, healed injury. This animal has survived many seasons, and survival itself becomes intimidating at this size. The female backs away gradually toward deeper water, while both males remain fixed in silence. The river current moves slowly between all three of you beneath gathering storm clouds overhead. Then, the larger male lunges. Not fully, a warning strike. Water explodes upward as jaws snap toward your snout without clean contact. You recoil immediately, while muddy spray erupts across both sails. The message is clear: leave. This may have been how many confrontations between giant predators ended. Controlled violence, designed less for killing than intimidation. Fatal combat benefits neither side unless absolutely necessary. Large predators survive by calculating risk constantly, especially during reproductive competition, where emotions humans might interpret as aggression are often simply evolutionary pressure expressed physically. But controlled violence still carries danger. The male advances again. This time, you hold position briefly, not challenging, testing. The larger Spinosaurus swings sideways through shallow water, jaws snapping hard enough to send vibrations through the channel itself. You twist away just in time, claws digging deep into submerged sediment for balance. Pain flashes across your injured shoulder immediately. Weakness. The male notices. That matters because predators interpret weakness instantly. Limping movement, delayed reaction time, uneven posture. Wild animals survive by reading vulnerability before opportunities disappear. The next attack comes faster. You retreat immediately this time, crashing backward through flooded reeds while the larger male surges forward several more steps before stopping at the edge of the channel. No pursuit. Victory achieved. The female remains deeper in the river, half hidden beneath fog and rain beginning to fall from darkening skies. And just like that, the encounter ends. Not with death, not even with clear hatred. Simply exclusion. That may have been the true brutality of prehistoric reproduction. Most individuals do not fail because they are weak enough to die instantly. They fail because another animal is slightly stronger, slightly healthier, slightly more experienced at surviving long enough to reproduce first. Evolution often looks less like triumph than narrowing probability. Rain thickens across the wetlands while thunder rolls overhead. You move alone again through flooded vegetation, shoulder throbbing from the encounter. Warm water drips from your sail while insects scatter around your movement in frantic clouds. And slowly, another realization settles into your mind. Even reproduction here is dangerous, especially for predators built like weapons. The river widens farther downstream into massive flooded plains where fish move beneath black water stretching almost to the horizon. Stormlight flashes across the surface in pale silver bursts, while distant crocodilian calls echo through the rain-dark wetlands. Somewhere out there, other Spinosaurus continue searching too. Some successful, some injured, some old enough that they no longer bother trying. And perhaps that loneliness shaped your species as much as hunger ever did. Because specialization isolates. Your body is too strange for open plains, too massive for dense forest, too dependent on rivers to wander far from water safely. So your world narrows toward these flooded channels where visibility disappears into reeds and storms and shifting mudbanks. A perfect environment for surviving, a terrible environment for finding one another. Still, the instinct remains, stronger every season. Because evolution does not care whether reproduction feels difficult, exhausting, or violent. It only cares whether enough individuals succeed, often enough to continue the species another generation. And somewhere beneath the rain, hidden inside these endless prehistoric wetlands, another nest will eventually be built beside another dangerous river. Another set of eggs, another generation born into heat, hunger, mud, blood, and uncertainty. All because creatures like you kept searching for each other in a world that made almost every encounter dangerous. The river looks peaceful from a distance. That is what makes it dangerous. Morning fog drifts low across the floodplain, while sunlight slowly burns through humid air above the wetlands. Fish ripple beneath dark water. Insects hover over reeds in dense, shimmering clouds. Somewhere far downstream, thunder rolls beyond the horizon, even though the sky above you remains clear for now. Everything appears calm. But calm in this world usually means something is waiting. You move carefully along the edge of a flooded sandbank, claws sinking deep into warm mud softened by recent rain. The river has expanded again during the wet season, swallowing old hunting grounds beneath rising brown water. Entire sections of shoreline no longer exist. Trees stand half drowned in newly formed channels, while drifting vegetation collects against submerged roots. The landscape keeps changing. That matters now more than ever. Because somewhere along these unstable riverbanks, you must choose a place to lay eggs. And there may not be a safe place at all. That may have been one of the greatest problems facing giant prehistoric predators. Survival alone was difficult enough, but reproduction required something even harder: predicting the future of an environment that never stopped shifting. Too close to the river, and floods could drown the nest. Too far from water, and hatchlings might die from heat, dehydration, or predators before reaching shelter. Too exposed, and scavengers would smell the eggs almost immediately. Too hidden, and rising mud or collapsing ground might bury them alive. Modern crocodilians face similar pressures constantly. Sea turtles lose nests to storms. Birds fail entire breeding seasons because temperatures shift only slightly. Reproductive success in nature often depends less on strength than timing. And timing here is brutal. You stop beside a stretch of elevated mud partially protected by thick vegetation. The ground feels firm enough beneath your weight. Nearby channels contain fish populations large enough to support feeding without long travel. Dense reeds conceal visibility from open floodplains. Temporarily, it seems ideal. But this world has taught you something important already. Ideal conditions rarely stay ideal for long. You lower your body slowly into the mud. The process feels exhausting. Your injured shoulder still stiffens during colder mornings, and your immense weight presses awkwardly through the hips whenever you remain on land too long. Water has become easier than solid ground over recent seasons. More natural, more forgiving. Yet eggs cannot survive underwater. So you stay here, exposed. The heat grows unbearable by midday. Humidity wraps around the floodplain like wet cloth, while insects gather constantly around your eyes and jaws. Sweat does not cool bodies efficiently in environments like this. Even giant animals struggle beneath prolonged heat stress, especially while expending energy digging, defending territory, and producing eggs simultaneously. Reproduction is expensive, not emotionally, biologically. Every egg represents transferred nutrients, minerals, water, protein, and energy pulled directly from your body into something fragile enough to be crushed beneath a careless footstep. And there may be many eggs. No one knows exactly how many Spinosaurus eggs a female could produce, but large dinosaurs likely relied partly on quantity because prehistoric mortality rates were catastrophic. Modern reptiles often lay numerous eggs precisely because survival odds remain terrible for hatchlings. Nature rarely promises fairness. It compensates with numbers. You begin scraping deeper into the elevated bank using powerful forelimbs. Wet sediment peels backward in heavy clumps, while muddy water slowly fills shallow depressions around the nest site. The smell rising from the ground is thick and ancient. Algae, roots, decaying vegetation trapped beneath layers of floodplain sediment. Above you, enormous insects circle lazily through humid air, and somewhere beyond the reeds, something is already watching. The terrifying thing about nests is how visible they become to ecosystems trained by evolution to exploit weakness. Eggs do not move. They do not fight. They concentrate nutrition into predictable locations. Even modern predators search breeding grounds obsessively during nesting seasons because the rewards are enormous. Ancient North Africa may have been even worse. Small theropods likely raided nests whenever possible. Mammal-like scavengers may have stolen eggs under cover of darkness. Crocodilian predators could easily destroy entire nesting sites near waterways. Floods might erase weeks of effort overnight. And larger predators posed another problem entirely. You smell one before seeing it. Blood, rot, theropod scent, fresh. Your body stiffens instantly, while the wetlands around you remain deceptively quiet. Wind moves through reeds. Fish break the surface somewhere downstream. Insects continue screaming across the floodplain. Then movement appears beyond the vegetation. A medium-sized theropod emerges slowly along the edge of the waterline, head low, eyes fixed toward the disturbed mud around your nest. It is not hunting you. That is what makes the moment unsettling. It is hunting opportunity. The predator circles cautiously, fully aware that attacking an adult Spinosaurus directly would be suicidal. But predators do not need to kill adults to exploit them. Eggs are easier. Hatchlings easier still. You rise immediately. The sail along your spine catches sunlight as muddy water drips from your body. A low warning sound vibrates through your chest, while the smaller predator freezes near the reeds. For several seconds, neither of you moves. Then the theropod retreats, not frightened, calculating. That matters because ecosystems remember nesting sites. Modern predators monitor breeding behavior constantly. Some birds follow crocodiles during nesting seasons, specifically to target vulnerable young. Mammalian scavengers return repeatedly to places where eggs were once discovered. And your nest will continue smelling like food for weeks. The realization settles heavily into your body as evening approaches. The eggs are not even laid yet, and already the world is preparing to kill them. Rain arrives suddenly that night. Warm tropical rain hammering the floodplain hard enough to flatten reeds and flood shallow channels within minutes. Water rushes through lower wetlands, carrying branches, dead fish, and drifting mats of vegetation toward the main river. You remain beside the nest through the storm. That detail raises one of paleontology's most difficult questions. Did Spinosaurus guard its young? No one knows. Some dinosaurs clearly demonstrated forms of parental care. Fossil evidence from certain species shows adults nesting in colonies, protecting hatchlings, or remaining near nests after birth. Other species may have abandoned eggs completely once laid. Your species remains uncertain. And uncertainty itself changes the emotional shape of this world. Because if Spinosaurus parents stayed near nests, reproduction became physically dangerous for adults already struggling against environmental pressure. If they abandoned nests quickly, hatchling mortality may have been horrifyingly high. Either possibility feels brutal. Lightning flashes across the wetlands. For one brief second, the entire floodplain glows silver beneath the storm. Flooded trees, rising water, endless reeds bending beneath warm rain. Then, darkness again. The river climbs higher overnight. By dawn, water has reached the lower edge of the nesting bank. Panic arrives instantly. Not emotional panic in the human sense, biological panic. The kind written deep into nervous systems by millions of years of reproductive failure. You begin scraping mud upward around the nest area aggressively, building elevation however possible while floodwater pushes closer through submerged vegetation. Every movement drains energy from an already exhausted body. This is another hidden truth about reproduction in ancient ecosystems. Sometimes, the environment itself becomes the predator. Not teeth, not claws, water, heat, disease. Temperature alone may have determined whether embryos survived. Modern reptile eggs often depend on extremely narrow environmental conditions. Too hot, and development fails. Too cold, and embryos weaken or die. Excess moisture creates fungal risks. Too little moisture dries the eggs internally, and floodplain environments fluctuate constantly. You remain near the nest for days as the river slowly stabilizes again. The hunger becomes difficult to ignore. Fish still move through nearby channels, but hunting while guarding a nest creates dangerous compromises. Leave too long, and predators may approach. Stay too long, and your own body weakens. This tension exists throughout nature today. Crocodilian mothers defend nests aggressively while risking starvation themselves. Birds abandon weaker hatchlings when resources collapse. Parenting in harsh ecosystems often becomes less about protection and more about impossible decisions. The eggs finally arrive beneath heavy afternoon heat, large, pale beneath wet sediment, fragile. You lower them carefully into the nest, while insects swarm thick around exposed mud. Thunderheads build again across the horizon, dark and swollen above distant wetlands. And suddenly, the entire future of your species feels terrifyingly small. Not giant predators, not towering sails, not dominance, just eggs buried beside unstable water in one of the deadliest ecosystems Earth has ever produced. The river smells different now. You notice it after several days. Sharper, rotting. Fish populations upstream have begun collapsing in some shrinking channels as temperatures rise again between storms. Dead aquatic animals drift through the wetlands, attracting scavengers from every direction, including larger predators. You see the crocodilian tracks first one morning beside the nesting bank. Huge, fresh, deep enough that muddy water still seeps slowly into the impressions. The predator likely investigated during darkness, while you hunted briefly upriver. It may not even have found the nest itself yet, but it knows something lives here, and that changes everything. The following nights become restless. You sleep lightly beside the reeds, while insects hum through the darkness and distant predators call across the floodplain. Sometimes fish splash suddenly nearby, sending instinctive panic through your exhausted body. Other times, silence itself feels threatening. Then, one night, the eggs begin moving. Tiny sounds emerge beneath the mud, scratching, weak tapping, life pressing upward against fragile shells. You lower your head closer to the nest, while warm wind moves through the reeds around you. Somewhere beyond the darkness, another predator bellows through the wetlands. The hatchlings are coming, and for one brief moment, despite all the death surrounding this world, the floods, hunger, predators, collapsing riverbanks, infections, storms, and endless violence, something else exists too. Continuation. Then the reeds nearby shift. You raise your head instantly. Another sound. Closer this time. Something moving toward the nest through the darkness. And suddenly you understand the cruelest truth of all. For most of your hatchlings, the struggle to survive is beginning in the exact same moment they are born. The river still remembers you. That is the strange thing about surviving long enough. The floodplains change, channels disappear, forests drown beneath new water, while old wetlands dry into cracked fields of black mud. Generations of predators vanish into sediment and bone. Storms reshape entire sections of the world without warning. But somehow, after all these seasons, you remain. Older now, slower, and far more dangerous looking than you actually feel. Morning fog drifts low across the river, while pale sunlight spreads slowly through humid air. Fish ripple beneath the surface in nervous flashes, though not as many as there once were. The river itself feels narrower than it used to, shallower in places, dirtier. Or perhaps that is only how age changes perception. The truth is difficult to separate anymore. You stand, half submerged, near the edge of a flooded channel, motionless except for slow breathing. The sail rising from your back bears scars accumulated across years of survival, pale streaks from territorial disputes, jagged tears from encounters near carcasses, old injuries healed imperfectly beneath thickened skin. Your body tells stories before you move at all, and lately, those stories have started sounding tired. The first sign was not weakness, it was recovery. Wounds stopped healing quickly. A torn claw remained painful for weeks instead of days. The shoulder injured seasons ago still stiffens heavily during cold mornings near the river. Long hunts leave exhaustion sitting deep inside your muscles long after feeding ends. And hunger itself has become stranger now, less sharp, more exhausting. You still need enormous amounts of food to survive, but the pursuit feels heavier each season. Your body no longer converts effort into momentum the way it once did. Every movement across mudbanks costs more energy than it used to. That may have been one of the cruelest realities facing giant prehistoric predators. Not sudden death, gradual inefficiency. Modern apex predators often decline this way. Older lions lose hunting success step by step. Crocodiles become slower during explosive ambushes. Sharks accumulate scars and parasites over decades until even successful feeding becomes inconsistent. Nature rarely grants dramatic endings. It wears bodies down slowly instead. You move deeper into the river, allowing water to support your weight, while fish scatter beneath your chest in silver bursts. The relief still feels immediate. Water carries part of the burden your limbs increasingly struggle to manage on land. Perhaps that is why older Spinosaurus individuals may have depended even more heavily on aquatic environments than younger ones. If your species truly evolved towards semi-aquatic specialization, aging may have intensified that dependence dramatically. Rivers offered buoyancy, easier feeding opportunities, cooler temperatures, and reduced strain on damaged joints. But rivers also create traps, especially for aging predators. You lower your snout into the current, searching for movement beneath suspended sediment. Tiny pressure shifts still travel clearly through the water. Your instincts remain sharp even when your body does not. Then suddenly, strike. Your jaws snap sideways through the current. Too slow. The fish escapes instantly. You freeze afterward, not angry, confused. That delay would not have happened years ago. The realization sits quietly inside your chest while ripples spread outward across the muddy channel. You are still enormous, still frightening, still capable of killing most creatures sharing this ecosystem. But speed has begun leaving you, and predators notice weakness long before weakness feels obvious internally. The floodplain around you remains alive with competition. Younger Spinosaurus now move through some river systems where you once hunted alone. You see their tracks often, deeper, fresher, more aggressive in spacing and movement. Occasionally, you glimpse them directly through reeds or storm fog. Large sails, powerful shoulders, bodies not yet carrying accumulated damage. The younger ones move differently, cleaner, more certain. That difference matters because survival in predator ecosystems depends heavily on tiny advantages: faster reaction time, better stamina, cleaner teeth, stronger immune response. One successful hunt can restore strength. One failed hunt can accelerate decline. And decline compounds itself. You notice it most clearly during the dry season. The rivers shrink again beneath crushing heat, while fish populations become concentrated into deeper, surviving channels. At first, the hunting improves. Fish gather densely enough that feeding becomes easier for a short time. Then the competition arrives. Crocodilians crowd the remaining waterways. Scavengers gather near every exposed carcass. Younger predators move aggressively through shrinking territories. And suddenly, every feeding ground feels crowded. The river ahead churns violently one evening as fish panic near submerged roots. You approach carefully through waist-deep water, expecting crocodilians, perhaps. Instead, another Spinosaurus bursts upward from the channel. Young, massive, healthy. The younger predator thrashes through the water with frightening force while pinning a huge fish against exposed roots. Mud and blood spray across the surface in violent waves. You stop immediately. The younger Spinosaurus notices you at once. For several seconds, neither of you moves. Warm wind drifts across the river, carrying the smell of fish blood and wet vegetation. Thunderheads gather low beyond the wetlands, while insects hum through the reeds around both predators. The younger animal lowers its head slightly. Not submissive, warning. You understand instantly. This feeding ground belongs to strength now, and strength is becoming harder for you to prove. Modern predators experience similar transitions constantly. Older lions lose territory to younger rivals. Aging crocodiles retreat from dominant feeding grounds. Wolves, pushed from pack leadership, often survive alone briefly before disappearing entirely. Predator hierarchies rarely remain stable. Nature replaces weakness without sentiment. You back away slowly into deeper water. The younger Spinosaurus does not pursue. It does not need to. That may be one of the hardest truths about aging in ancient ecosystems. Eventually, survival stops depending on defeating rivals and starts depending on avoiding confrontations you no longer win consistently. The storms return again weeks later. Heavy tropical rain floods the wetlands while lightning flashes across endless black water stretching through the floodplain. Entire channels overflow overnight. Trees collapse into swollen rivers. Dead fish drift through muddy currents beside uprooted vegetation. The world feels unstable again. But now, instability frightens you differently. When younger, storms represented opportunity, new feeding grounds, displaced prey, changing territory. Now they represent risk, bad footing, hidden currents, injury. Your body no longer recovers easily from the stakes. That reality becomes terrifyingly clear during a nighttime crossing through flooded wetlands. Rain hammers the river hard enough to blur visibility almost completely. Water levels have risen across the floodplain, swallowing familiar landmarks beneath black, moving currents. You push slowly through waist-deep water toward higher ground, while thunder shakes the sky overhead. Then the current changes. A submerged channel drops suddenly beneath your front limbs. Your body lurches sideways. Pain explodes through your shoulder instantly as water surges across your sail and neck. For several terrible seconds, the river pulls you downstream against your own weight. Young muscles might have corrected faster. Your body hesitates, and hesitation nearly kills you. You slam sideways into submerged roots hard enough to rattle your skull, while muddy water closes over your jaws completely. Panic surges through your nervous system as the current twists your massive body awkwardly against hidden debris beneath the surface. The river does not care how powerful you once were. It only cares about gravity and movement. You wrench yourself free eventually, crashing onto shallow ground downstream beneath pounding rain. Your shoulder burns violently now. One hind leg drags slightly when you stand, and suddenly another terrifying possibility emerges. What if you survive the predators, but simply become too damaged to keep moving? That may have happened often in prehistoric ecosystems. Large predators likely died from accumulated injuries, infections, exhaustion, or environmental accidents far more frequently than dramatic combat. Fossils preserve bite marks and healed fractures showing survival after trauma, but survival itself may have gradually reduced quality of life over time. Ancient ecosystems did not need mercy. They only needed persistence long enough to reproduce. You rest beside the flooded riverbank until dawn. The rain finally weakens into soft mist drifting across black water and drowned reeds. Fish still move beneath the surface. Insects return gradually with the warming air. Somewhere far across the wetlands, another giant predator bellows through the fog. The world continues. It always continues. But something inside you understands now that you are no longer part of its future in the same way. You are part of its memory. The younger predators will inherit these rivers eventually. They will hunt the deeper channels, build nests beside unstable floodplains, carry fresh scars across stronger bodies. Some will survive long enough to become old themselves. Most will not. The river ahead glows gold beneath early sunlight, while your reflection trembles across the current. Enormous sail, elongated jaws, scarred skin, body shaped by millions of years of evolution and decades of survival. You still look like a monster, but age has revealed something quieter beneath that image. You were never truly built to conquer this world forever. You were only built to endure it slightly longer than the things that failed before you. The last day does not arrive with drama. That is the first thing you notice. No great battle waits for you beside the river. No legendary final hunt beneath burning skies. No moment where the ancient world pauses to recognize the death of one of its oldest predators. The floodplain simply wakes as it always has. Warm fog drifts above black water before sunrise. Insects scream through dense reeds. Fish disturb the surface in soft ripples beneath the current. Somewhere far downstream, thunder rolls faintly beyond the horizon, even though no storm has arrived yet. The world continues breathing around you. But your body no longer moves with it correctly. You stand at the edge of a shallow channel while morning light slowly spreads across the wetlands. Your shoulder burns constantly now. One hind leg drags slightly through the mud with every step. Several teeth along your elongated snout are cracked or missing entirely, leaving parts of your jaws strangely uneven when they close. And the hunger has become unbearable again. Not sharp like it was when you were young, heavy, endless. The kind that drains strength instead of creating urgency. You lower yourself carefully into the river because water still helps carry part of your weight. The relief remains immediate, even now. Cool currents slide along scarred skin, while submerged mud softens beneath your claws. But even the river feels different lately. The fish are harder to find, or perhaps harder to catch. That distinction matters more than you want to admit. The late Cretaceous floodplains of North Africa were likely unstable ecosystems even during productive periods. Seasonal droughts, floods, shifting river systems, and changing prey distributions may have constantly reshaped survival conditions. Large, specialized predators could thrive there for years and then suddenly struggle when environmental balance shifted only slightly. And specialized predators often suffer first. You move slowly through deeper water, searching for movement beneath the muddy current. Small fish scatter around your body easily enough, but the larger prey you need now remain frustratingly absent. You wait. Stillness has always been part of your survival. Then, finally, movement. A large fish glides through submerged roots ahead. Your body reacts automatically. Strike. Pain explodes through your jaw the instant your teeth slam against wood hidden beneath the current instead of flesh. The impact rattles through your skull while the fish vanishes instantly into deeper water. You remain frozen afterward, water dripping from your snout. The failure feels different this time, not temporary, final somehow. Because deep inside your instincts, something has already started understanding what your body refuses to say clearly. You are running out of strength faster than the river is providing food. That is often how apex predators die in nature. Not suddenly, gradually. A missed hunt becomes several missed hunts. An injury slows movement slightly. Hunger weakens muscles. Weakened muscles reduce hunting success further. The cycle feeds itself until even minor environmental pressure becomes catastrophic. Modern lions, crocodiles, sharks, wolves, many large predators disappear this way quietly, far from dramatic human imagination. The floodplain offers no sympathy for aging hunters. By midday, the heat becomes crushing. Warm wind rolls across exposed mud banks, carrying the smell of stagnant water and decaying fish from shrinking side channels. Dragonflies swarm above black pools where oxygen levels have dropped low enough that dead aquatic animals float near the surface. You move toward one of these channels slowly. Carrion no longer disgusts you. It never truly did. Most large predators scavenge opportunistically when survival requires it. Fossil evidence suggests theropods likely did the same. A giant body cannot afford unnecessary pride. The carcass lies half submerged near exposed roots. Some large fish or aquatic reptile already rotting beneath the sun. Insects cover the exposed flesh so densely that parts of the body appear to librate. You approach carefully and immediately stop. Fresh tracks surround the carcass. Younger Spinosaurus. Several. The mud impressions are deep, recent, overlapping each other around the feeding ground. Blood still drips into the water nearby. You arrived too late. That realization settles heavily into your chest because it means more than missing one meal. It means the ecosystem has already begun moving on without you. You back away from the carcass slowly, then freeze. Movement behind you. A younger Spinosaurus emerges from the reeds silently enough that you almost do not see it at first. Huge sail, clean teeth, powerful shoulders, water sliding easily from dark skin as it steps into the channel between you and deeper water. The younger predator stares directly at you. Not aggressive immediately, just aware. Your body lowers slightly from instinct more than strategy now. The river around both of you remains perfectly still beneath the heat. Years ago, perhaps this encounter becomes violence. Now, it becomes arithmetic. The younger predator is healthier, faster, stronger, and both of you understand it instantly. The younger Spinosaurus steps toward the carcass without taking its eyes off you, claiming it. You do not challenge the movement, because your body already knows the likely outcome. That may have been one of the cruelest moments in the lives of aging prehistoric predators. Not losing dominance dramatically, but slowly recognizing when direct competition becomes mathematically unwinnable. The younger predator tears flesh from the carcass while blood spreads across the shallow water. You leave. The riverbank feels steeper than it used to. Mud grips your injured leg harder with every step. Even breathing beneath the afternoon heat takes effort now. And somewhere inside your fading instincts, another realization finally becomes impossible to ignore. You may not survive this season. The storms arrive again toward evening. Massive black clouds gather over the floodplain, while distant lightning flickers through curtains of rain far across the wetlands. Warm wind bends reeds flat against the water as pressure changes ripple through the river. Most animals begin moving before storms fully arrive. You remain near the shoreline because movement itself has become exhausting. Rain starts slowly, then all at once. Sheets of warm tropical water hammer the floodplain hard enough to blur the horizon completely. Channels overflow almost immediately, while muddy currents surge through low wetlands, carrying branches, dead fish, and uprooted vegetation downstream. The river rises around your legs. Normally, you would move toward higher ground early. Tonight, you hesitate too long. A collapsing section of saturated riverbank gives way beneath your weight without warning. Mud breaks loose. Your injured leg slips sideways, and suddenly, gravity takes control. You crash hard into deeper water while collapsing sediment pours down around your body in thick, black waves. Pain tears through your shoulder instantly as the current catches your massive torso sideways. You try to rise. The mud gives way again. The river pulls harder. Panic surges through your nervous system because instinct remembers something ancient and terrifying. Large bodies trapped in unstable ground rarely escape easily. You thrash violently, claws digging into collapsing sediment while water crashes across your sail and neck. The current keeps twisting your body sideways, forcing weight against injured limbs that no longer respond correctly. Years ago, strength might have solved this. Now, every movement burns energy you no longer have. You finally drag yourself partially onto a shallow mudbank downstream, but the effort leaves you trembling with exhaustion. One forelimb barely supports weight at all anymore. Rain pours across the wetlands in endless sheets, while thunder shakes the sky overhead. You try to stand again. The injured limb collapses instantly. For several long moments, you simply remain there beside the river, breathing heavily while muddy water rises slowly around your body. And, somewhere nearby, the ecosystem notices. The first scavengers arrive before dawn. Not large predators yet, smaller ones. Bird-like scavengers circle the shoreline cautiously, while insects gather thick around exposed wounds torn open during the fall. The smell of blood spreads quickly through humid air. You lift your head weakly. The scavengers retreat, but not far. They understand something important already. You are no longer fully dangerous. Modern ecosystems behave the same way. Scavengers monitor weakness constantly because dying predators become enormous food opportunities. Hyenas follow injured lions. Birds gather near exhausted crocodiles. Nature wastes very little. The rain finally stops near sunrise. Fog drifts low across flooded wetlands while pale golden light spreads slowly through the storm clouds overhead. Fish still move through the shallows nearby. Insects still scream through the reeds. The world remains beautiful. That feels strangely important. Even now, at the edge of death, the floodplain has not become evil or cruel in some dramatic human sense. The river is simply continuing its endless cycle of feeding, drowning, eroding, growing, and consuming life exactly as it always has. You lower your head beside the water. The current moves gently past your jaws. Somewhere downstream, another Spinosaurus bellows faintly through the morning fog. Younger predators are already hunting the channels where you once fed. Somewhere hidden in the wetlands, hatchlings are being born into nests beside dangerous rivers. The cycle continues without hesitation, And perhaps that is the final truth this world has been teaching you since the moment you cracked open your shell beside the ancient floodplain. You were never separate from the river. Not really. You were only one temporary shape it carried for a little while before carrying everything onward again. Thanks for spending tonight with Sleep Documentary. I hope this journey through the ancient rivers of prehistoric Earth helped you relax and drift a little deeper into sleep. If you enjoyed the video, don't forget to subscribe. It truly helps the channel grow. Sleep well, and I'll see you again in the next journey through the ancient world.